Did you know 90% of developers can't write a recursive factorial on the spot? Today, you'll master it in under 3 minutes. By the end, you'll understand exactly how recursion breaks this problem down, and you'll never blank on it again. Factorial means multiplying every whole number from your input down to 1. For example, 5 factorial is 5x, 4x, 3x, 2x, 1, which equals 120. The challenge is doing this without loops, using recursion instead. Here's the intuition. First, we need a base case to stop infinite calls. When n is 0, return 1. Then we break the problem into a smaller version, n times factorial of n1. Finally, we combine the results by multiplying them together. We start by defining the function factorial that takes one argument, n. This is our entry point. Every recursive call will come back here, but with a smaller value of n. This defines the reusable function boundary, so the inputs and final answer have a clear place to live. Here's the critical base case. If n equals 0, we return 1. Without this, the recursion would never stop. It would keep calling factorial 1, factorial 2, and crash. This is what makes the whole thing work. This line does the magic. Return n multiplied by factorial of n minus 1. It breaks the problem into a smaller version of itself. For example, factorial 5 becomes 5 times factorial 4. Each call gets simpler until it hits the base case. This is our test block. We set num to 5, call factorial, and print the result. The if name, APRI, main abide part, ensures this only runs when we execute the file directly, not when it's imported elsewhere. This condition is the decision point, so we only return or branch when the required case is actually true. When we run it, we get factorial of 5 is 120, exactly what we expected. This proves our base case and recursive call work together perfectly. Try changing num to 3 or 7 to see different results. Time complexity is O(n), because we make n recursive calls. Space complexity is also O(n). Due to the call stack, each call waits for the next one to finish. There are exactly n plus 1 function calls, from n down to 0. Remember this mental model. Recursion breaks a problem into smaller identical problems, solves the smallest one directly, base case, then combines the results. This pattern applies to factorial, Fibonacci, tree traversals, and more. Pause the video and try changing the base case to return 0 instead of 1. What happens? Then try adding input validation for negative numbers. You've got this. Got a real interview coming up? CrackInterviewAI. Yases me. Etsius minda psarfo. Solves aburasmi essays elves questions like this live on the call. Start free at CrackInterviewAI.in.